Alright, so for this podcast, we're going to be focusing on two types of special lines, parallel and perpendicular lines. Okay, so let's just get some background as to what those are. This first question says, what does it mean for two lines to be parallel? Draw an example of parallel lines below. Alright, so parallel lines are lines, well, right here what it means. Lines that are parallel are lines that never touch or intersect. Okay, that's really what it means. There are two lines that will never touch. So for some examples, now the direction of the lines doesn't matter. They could be going across, but those two lines, if they went forever, which is what the arrows mean, they'll never touch. They could be going straight up and down, but if they're both doing the same thing, those are parallel to each other. They can go diagonal as well. Okay, so they're parallel if both lines were to extend and never touch. That's basically what they mean. So if that's what they mean, here's what's the important part, the key point. Think about what you've been doing for this chapter and last chapter, right? We've been focusing on two main parts of the line, either the slope or the y-intercept, right? So if you think about it, these are going in the same direction. Well, what would make them go in the same direction? Well, that would have happened if they have the same slope. So parallel lines have the same slope. That is the key. Okay? But they do have different y-intercepts. Okay? So they can cross the y-axis at different points, but they're going to be going in the same direction. It's all about having the same slope. Alright? Now the next type of line is perpendicular. What does it mean for two lines to be perpendicular? Now these lines will touch, but they don't just touch any way. They have to touch in a special way. Okay? So perpendicular lines are lines that intersect at a 90-degree angle. Okay? And typically, like if two lines were, well, we'll do that in the example. So let's draw some examples of perpendicular lines. Alright, so let's say I had a line going straight up and down. Well, to make 90 degrees, the other line would have to be going horizontal. Okay? But once again, they can be going diagonal. Like I could have a diagonal line this way, and this would be diagonal. The key is they have to touch and make a 90-degree angle. And usually you'll see like a little square there. That's showing you that it's 90 degrees. Okay? So once again, it's not any lines that intersect. Like if these two can intersect, but none of these angles make 90 degrees. So that's not perpendicular. It's got to be at 90 degrees. Alright, so what's the key here is parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. Okay, so that's basically you have to make two changes to the slope. You have to make it the opposite sign and make it a reciprocal, which is flipping the fraction over. Okay, so let's write down some examples of opposite reciprocals. So let's just start with an easy fraction. Let's say 1/3. So if one line had a slope of 1/3, to be perpendicular, the slope would have to be opposite. So this is a positive 1/3. We'll make it a negative. That's the opposite part. But then the reciprocal means we have to flip the fraction. So 1/3 becomes 3/1. Okay, so these two slopes will be perpendicular. This is opposite reciprocal. Okay, let's take a whole number. Okay, let's take 5. So let's say the slope is 5. Now, once again, like we did with slope, it's easier to look at it as a fraction, so I can make 5 as 5/1, right? So a perpendicular slope would be opposite. This is positive, we'll make it a negative. And then if we flip it and do the reciprocal, it'll be 1/5. So if we had a positive 5 slope, negative 1/5 would be perpendicular. Alright? One last quick example here. Let's take negative 2. Negative 2. So once again, if I throw that over 1 so I can see the fraction, negative 2/1, that means this one was negative, therefore this one is positive. But then I do the reciprocal. Okay? And just as a quick way to check, what it says here is slopes of perpendicular lines, two non-vertical lines are perpendicular if the product of their slopes is -1. So if you were to do this times this in your calculator, you'd get -1. This times this would be -1. This times this. So that's just a way to check it. But just remember to make two easy changes. Make it opposite sign, flip the reciprocal. Okay? Alright, so let's take a look at some problems here now. Alright, so on the next page, so we're going to actually write equations of parallel and perpendicular lines. Alright, so number 1, it says write the equation of the line that is parallel to y equals 2x minus 5 and goes to the point negative 3, 5. Well, let's go back and look what's important. We know that we want a parallel line. Here's the line they're giving us, and it has to go, the new line has to go to this point. Okay, so basically we're taking this line and making a parallel line that goes through this. Okay, so it's like this is the old stuff, this is going to be the new stuff. Alright, so the first thing we need is the slope, our m. Remember, parallel lines have the same slope. So if I look at the original line, the slope is right here, it's 2. Therefore, my new line will have a slope of 2. Alright, same slope, that's all that really matters. So now to actually get the equation, we're going to first put it into point-slope form because we have a slope and we have a point, right? If that's all we have to use point-slope form. We are not going to use this equation anymore. This is the old line. We are only using the slope from there. That's all we need. So forget that now that it's basically forgotten now. So remember, point-slope is y minus y, and here my y is 5, equals, the m is 2, that's my new slope, x minus negative 3. And then to clean that up, I'll just turn that double negative into a plus. Okay? And so that's the setup. And then to finish it and get the slope-intercept, remember we just solved this. So here we're going to have y minus 5 equals 2x. Now it's times positive 3 plus 6. And then we're going to do plus 5. And so the final will be y equals 2x plus 11. So basically this is now perpendicular to this if we were to graph those two. Okay? Alright, let's try another one. Now number 2 says write the equation of a line that's perpendicular to y equals 2x minus 5 and goes to the point negative 3, 5. So now we're looking for a perpendicular line to this line, and it goes to this point. So it's the exact same problem as number 1, except for now in writing a parallel line, we're going to write a perpendicular line. Alright, so we start off with the slope, which is the most important thing. So once again, on this original line, the slope is 2. Perpendicular line, remember, the slope is not the same, it's opposite reciprocal. So if my slope is 2, let's throw that into a fraction. Our new slope, this is positive, our new slope is negative, and I'm going to flip the fraction. So it's negative 1/2. Okay, so now we're going to use our new slope, and it's got to go to this point, and we're going to put it in point-slope form. So it's still going to be y minus y, and our y is 5, equals, now my slope is negative 1/2. X minus the y is negative 3 again. Clean that up to a plus 3. And then we just solve it like normal. Distribute first, so nothing changes here, it's y minus 5. This times this is negative 1/2 x, and then this times this, if you use your calculator, negative 1/2 times 3 is going to be minus 3 over 2. Okay? Now we're going to do the plus 5 on each side. Okay, don't worry about that fraction. As long as we know what we're doing, the calculator will do it for us. So here we have y equals, the slope is negative 1/2 x. And now look, let's go to our calculator. This is negative 3/2 plus 5. Alright, so let's put in our fraction. Negative 3/2 come out of the fraction plus 5. And we get 7/2. Alright, and that was a positive. Alright, and you can have a fraction for the y-intercept as well. That just means crossing the axis in between 2 points. Okay, so this line is now perpendicular to the original. Okay, so as you can see, nothing is new. You know, it's still point slope and changing it. The only new thing you're thinking about is parallel to the same slope, perpendicular, opposite reciprocal slope. Okay, so I want you to pause the podcast, try numbers 3 and 4 now, and then when you have those done, play the podcast again to check your answers. Alright? Alright, so for these next 2 practice problems, the number 3 asks you to write an equation of a line that's parallel to this line, y equals negative 4x plus 2, and goes through the point 8, 4. So your first setup, you're going to put it in point-intercept form. This is your, point slope form. and the slope is the same for parallel. So the -4, I still keep my slope -4. It's got to go to these new points, so I just plug that in. By the time you simplify and solve this, the final answer is y equals -4x plus 36. So this equation is parallel to this one, same slopes. Okay? Alright, the last one, write an equation of the line that is perpendicular to y equals 1/3 x plus 3 and goes to the point -1, 2. So here's my point slope form. Alright, now once again, here's the most important part. My slope right now is 1/3. Perpendicular is not the same, it's opposite reciprocal. So if I take this positive 1/3, my new slope is a negative. If I flip it, it's 3/1. Now if you plugged it in this way here, that's okay too. It means the same thing. I just cleaned it up. -3/1 is just -3. Okay, but that's how we get the new slope. Distribute, simplify, solve for y. So the final equation is y equals -3x minus 1. That is the equation for the perpendicular line that goes to that point. Okay? Alright, now going through the unusual lines. Okay, still talking about parallel perpendicular, but now we're going to be talking about them with horizontal and vertical lines. So here you're going to remember your Hooy-Vux from last chapter. Alright, if you still remember your Hooy-Vux, this is going to be really easy. You don't even have to really do much work as long as you know the shortcuts. Okay? So it says graph the lines below. So remember, y equals, when it only has one letter, it's a Hooy-Vux. And because it has the y, that's a Hooy line. So a Hooy line, remember, is horizontal. So this line is horizontal at 4. 1, 2, 3, 4. Alright, so here's our line, y equals 4. Alright? So we're going to do some questions based on this line. Alright, so the next part says, in order for a line to be parallel to this line above, it would need to be a. So think about this. We just did a Hooy line, horizontal. And remember, the slope is here. It's a 0 slope. So if it's parallel, I want it to be the same slope, so it's still going to be a Hooy line. So it's still going to be horizontal, because it'll have the same slope. Okay? Now, in order for a line to be perpendicular to this line, it would need to be a what kind of line? So perpendicular is opposite slope. So kind of the way to think about it, remember 0 would be like 0 over a number. So if I flip it, it's going to be 1 over 0. Remember, when 0 is on the bottom, it's undefined. Undefined would be a Vux line. So perpendicular to horizontal would be vertical. Okay, it's basically just the Hooy and the Vux are opposite of each other. Alright, so now let's do a question about it. What is the equation of the line parallel to the line above that goes to the point 1, 7? So we're still coming back to this line. I want it to be parallel, so that means it's still going to be a Hooy line. That means my equation still starts with y, because remember, in a Hooy line, the equation is y equals. And then here's all you're going to do. Well, look here. Remember my points? The first number is the x. The second number is y. This says y equals. And what does y equal here? Y equals 7. Okay? And just to kind of prove that, like if I come back up here, the point is 1, 7. So 1, 1, 2, 3, 4, 5, 6. So we want it to go through this point. So if I draw a line horizontal to the original through that point, it's y equals 1, 2, 3, 4, 5, 6, 7. Okay? You can just use your shortcut there. Alright, now the next equation says, what is the equation of the line perpendicular to the line above? So remember, the line above was y equals 4. That's a Hooy line. Perpendicular is opposite slope, so we're going to use a Vux line. So now look, our equation is not going to be y equals, it's going to be x equals, because it's going to go the opposite way. And x equals what? 1. And just to kind of show that here, if it's going to go through this red point, it's the same point. So perpendicular through that line will go like this, because that makes it 90 degrees. And that line is at x equals 1. Okay? So that's how your Hooy-Vux can still help you here. Okay? Let's try a little more practice. Now our original line is x equals -2. Because it's x equals, that's a Vux. It's a vertical line. So it'll go vertical where x is -2. Alright, so this is going to be the line we're basing everything on. So in order for a line to be parallel to the line above, it'd be the same slope or same type of line. It was vertical. It would still be vertical it would still be a Vux line to be parallel. But then in order for it to be perpendicular to this, it'd have to go the other way, which is horizontal. So parallel, we go from Vux to Hoi. We go from vertical to horizontal. Okay? Alright, so now some actual problems here. What is the equation of the line parallel to the line that goes through the point 4, 5? So here's our original line, x equals 2. We want a line that'll go through the point 1, 2, 3, 4, and then 5. 1, 2, 3, 4, 5. So how would I get a line parallel to this that would go through here? Well, it would look like this, but I don't even have to do all that. If I use my shortcuts, parallel, we have a Vux line. Parallel would be the same undefined slope. It's still vertical. Therefore, it's still x equals. But now our x equals 4. And if we look back up here, this new line is x equals 1, 2, 3, 4. Okay? Now the last one says, what is the equation of the line perpendicular to the line above that goes to that same point, 4, 5? So remember, our original equation was x equals negative 2. That is a Vux line. So perpendicular would not be the same undefined slope. It would be a 0 slope, which is a Hoi line. It's opposite, right? So now my equation is not x equals. Now it turns to y equals. And what does y equal? 5. Alright, so that's how you can use your Hoi Vux to help you. Still the same idea. Same slope, same line, opposite slope, opposite line. Okay? Alright, let's go to the last bit of practice here. Alright, so number 5, what is the equation of the line parallel to this line, y equals 10, and goes through this point? Alright, so let's think about this. This is a y equals, this is a Hoi line. Alright, so I don't have to do a lot of work here, I just got to think it through. This is a Hoi, parallel would be the same, so it'll still be y equals. Right? 0 slope, 0 slope. And what does y equal? 6. That's all we have to do. Okay, if you really get the Hoi Vux, there's really not a lot of work. Alright, next one, number 6. What is the equation of the line perpendicular to y equals negative 5 and goes through this new point, 2, negative 5? Alright, so let's walk through this. So this is a Hoi line, right? Y equals. It's got a 0 slope. We want perpendicular, so I don't want a 0 slope, I want the opposite. So the opposite of Hoi, we're going to turn this into a Vux line. That means our equation is going to be x equals. And x equals what in this case? 2. So this will be perpendicular to this. It's just that easy. Alright, so just go ahead and pause the podcast again, do these next two, and then unpause it for the answers here, okay? Alright, here are the two answers for number 7 and number 8, okay? So once again, just to go through this, number 7, we want a parallel line. The line they've given us is an x equals, that is a Vux line. So a parallel line will still be the same Vux, so it's x equals, and here x equals 7. The last one, we want a line perpendicular to this. So what have they started with? They've given us a Vux line, because it's x equals. Perpendicular will be the opposite. Opposite of Vux is Hoi. So our new line will be y equals. And y equals what on the new point? Negative 2. And that's it. Okay, so before you go into the practice packet, if you have any questions, let me know.